but hopefully it'll be useful or interesting to some people. My name is Brian Guthrie. I just graduated this Saturday from Northeastern University, and 5 years. And the project arose because I was taking a software development course, and the instructor said about halfway through the course, whatever language you're using for your project, I want you to go out and find the contract system for your chosen language. For those of you not familiar with, is everyone here familiar with the concept design by contract? Is there anyone who's not? Okay, so I'll talk about that a little bit. Design by contract, the idea is that you can express the interface of your code and constraints on your code separately from the implementation of the methods, and apply them to apply contracts separately from the actual code itself. And I'll show you examples of that. But so anyway, he told us to go out and find an example for our language. And I saw a couple for Ruby, and I didn't really, I wasn't impressed with any of them. This is before I found Florian Gross had apparently written some crazy incredible thing. His is very cool, but I think mine is cooler actually. And we'll get into that. But so this is called Handshake, which I think is a very cute name. I'm very proud of the name. I figure that's essential, right? Pretty good. Does this work? Maybe not. Okay. Oop. So, there we go. Okay. So, the goal of a contract system is to express an object interface explicitly and enforce constraints on that interface. And it uses the metaphor of a business contract to express that concept. So, the receiver, right, a method, expects certain arguments from whoever calls it. And the caller expects certain return values back. These are assumptions that are built into your code, right? Like when you develop a method, you assume that you are going to receive certain arguments, that you are going to assume that certain things are true about those arguments, particularly in Ruby, which is a dynamically typed system, and those things typically aren't expressed explicitly as part of the object. And so the goal of Handshake is to provide a really, really flexible but informal framework for expressing those constraints so that they're explicit and so that they're enforceable, so that when you actually run this code, it'll enforce the things that you say should be true for the arguments and for the return values. So that talks a little bit more about. So there are three things you can do in Handshake, basically. And the syntax is that you apply it to a class that you're writing. But there are three things that it allows you to do. You can use class invariants. And class invariants are things that must hold true at every point during the existence of an object. And so before a method is called, it checks to see whether the invariant holds, and after the method is called, it checks to see whether the invariant holds. And if the invariant is violated, then it throws an error. Second thing is method signatures, which are really interesting, cool. Like, they're not like Java method signatures. Like, these are really expressive ways of talking about what the arguments, what the constraints are in the arguments for your methods and what the return values are. And the third thing is you can apply pre and post conditions to your methods, like a conventional contract system like Eiffel. And those are useful for when you have combinations of arguments and you have to express some constraint in terms of multiple arguments. And you group assertions together and you can express complex logic that way. So class invariants, here's the very simple case. You say you want to build a class like a non-empty array, and the invariant on that is the array can never be empty. So you inherit from array, and you include Handshake, and you have a very simple invariant here. It's just a block. It's evaluated within the context of the object, and if at any point the array is empty, it's going to throw an error. Method signatures are composed of clauses, and any object that implements the triple equals method is a valid clause. If you guys have used the triple equals method, whenever you do a case statement, that's how the case statement works, is it has this triple equals method, which is sort of a convenient equality that Ruby uses. So, like a regular expression, triple equals a string, is equivalent to string equals tilde, that regular expression. Or a class triple equals an object is equivalent to that object is a class. Does that make sense? Okay, cool. So, so you can use any of those pre-existing built-in objects that implement triple is equals as a clause. You can build your own and you can combine them together. And so on the next page, this is sort of a very simple example of that. So we have some image class, and the base constraint for our image is that we want it to accept a file name as the first argument of the constructor to initialize. So we say contract accepts a string and returns self. And the rest of the method is as you'd expect. But we can get more precise with that. You can express it as a regular expression rather than just a string. And because the regular expression implements triple equals, and we'll check whatever argument is passed into it against that regular expression, you can get even more complex that way. And eventually you want to move to a point where all this stuff is expressed as an attribute of the project that you're working on. So you can build rich clauses that are specific to whatever it is you're building. So say you want to be able to reuse this clause over and over again, and you don't want to express it as a regular expression. You want to say image file. Is this thing an image file? Which is to say, is it a string, and does it contain JPEG, PNG, GIF, or BMP? That is a trivial case. And so that's what we've done here. We're saying all question mark, is it a string, and does it satisfy that regular expression? And so then we can actually write contract image file question mark return self. And you can also do fancy things with accessors. So I've built an accessor here, a reader and a writer, that will actually contract check the read value and the write value against that signature. So you can also express the rest of a signature as well. You can use variable arguments that get passed into your method by enclosing them within a list. And you can actually check anonymous blocks. There's a mechanism for applying a contract directly to whatever block gets passed into the method. And here's sort of an example of other things that you can do with clauses, and these are all built into the library. So you can ask, is the argument that I've just received, is it a list of many strings? Or is it a hash, and does it have the following, does it have only the following, the following two keys? Is it a hash, and does it only have foo and bar? Or is it a hash composed of a symbol to a string? You can also do things like duck typing, and people do duck typing anyway, but the cool thing about that is that it's explicit and expressed as part of the contract rather than cluttering up the method body itself with all of these checks. And you can also, if you have complicated code and you want to be able to check if something is a class that will exist at runtime but doesn't exist in the code yet, you can use is question mark. And finally, you have pre and post conditions, which are sort of like Eiffel style. Eiffel is the language that first came up with this idea of design by contract. And Bertrand Meyer, the inventor of Eiffel, actually he's copyrighted the term design by contract, so I shouldn't refer to it as that way. But the idea in Eiffel is that you can have these require and ensure, these pre and post conditions on each method, and that they become part of the interface of that method. And so I do that too. I don't think they're as cool as the signature stuff. Like the signature stuff is really what's most useful to me anyway. But it's useful in situations where you really need to express contracts in terms of multiple arguments. And so if you have like two lists and you want to make sure that the total of the size of the two lists always equals 10, you can say, well, I guess in this case I did an integer, but yeah. So that's the idea of pre and post conditions. And you can, the block just expects assertions. I've extended it so that all of the assertions within test unit are available for use within that block. And then when an assertion is violated, it wraps that as a contract violation. It raises a contract violation. I'm gonna, once this is done, I'm gonna pop into IRB and run through a few examples of this concretely so you can actually see what happens when we define a contract on a class and when that contract is violated. And well, this is the IRB session, but it'd be a lot easier if we just did it live. So a couple of notes on inheritance. You can actually define contracts on a class, and all classes that extend that class will inherit those contracts, or they can redefine their own contracts in terms of the superclass. There are interesting constraints on what, formally in terms of type inheritance, there are interesting constraints on what shouldn't be allowed for subclasses to do to override superclass contracts, but I don't get so far into that. If anyone's curious, I can talk about it, but it's not, I think for most Ruby stuff, type inheritance is more a matter of reuse rather than actually inheriting the attributes of a supertype often. So anyway, esoteric. But as you can see, you can actually specify the name of the method explicitly, and it will apply the contract to that string without actually having to define the implementation of the method in the class body. So if you wanted to have a specifically typed string array that was a subclass of array, you can override just the contract for that method, and it would apply it to all calls to the append method. So contract works by, when you include it in a class, it overrides the new method of that class. So you have class foo include handshake. When you call foo.new, instead of returning an instance of foo, it returns a proxy object that wraps the instance of foo. And that acts as a barrier between the outside world and that object. And everything that passes across that barrier in one direction or the other gets checked. Nothing within the barrier gets checked, but everything that passes across it. So if you have an external object that calls some method on the original object, the proxy will check all the arguments that pass across it, all the invariants. So that's the mechanism. And the proxy object is designed to look and act exactly like the original object. It makes sure that when you use toString, it uses the underlying toString. It makes sure that the object ID returns the same value. So the idea is that it should look identical except for the fact that contracts that pass across it are checked. One side effect of this is that you probably shouldn't use it when you're doing a lot of other stuff with really complex meta-class hackery. You wouldn't necessarily want to use it in most places within your Rails project, but if you're doing an external library, and you're not doing things like overriding a new method, then you're probably fine. So here's sort of the structure illustrated a little bit. We have the original object in here. This is your class foo, and it implements the following four methods. And then we have the proxy object that wraps around that, the instance specific here. And then the class itself, which defines these contracts. And so the proxy intercepts the method calls using method missing, and it also overrides any superclass methods that it needs to, so that it becomes completely transparent, and then checks the invariants, the method signature, and the preconditions, calls the original method, and then checks that value against the return contract, so the post conditions and the return conditions from the signatures. Finally, the invariants again, and returns the correct value. Also does a couple of other small things. You can define a class as abstract. You can enforce calls to private methods within the class by using checked self. Normally, because of this, there's this barrier, right? If you call a private method within the object internally, the private method won't be checked. And I can show you that in a little bit. And you can also get access to the original object if you call unchecked on what you know to be a proxy object. Also, the most important thing with Handshake is that all of this stuff is not fast, right? I mean, it slows down your object considerably. So, and it probably never will be fast. I mean, whenever you're imposing this kind of barrier between the outside world and an object, there's a whole lot that has to go on in terms of checking all of the arguments and so forth. And so Handshake will only run if you run Ruby in debug mode. If you set $debug is equal to true, or if you call ruby.d, then it will actually check and enforce your contracts. And if you don't, then it'll allow you to define them, but it won't check anything. So you can preserve the integrity of the code when you run it in production mode. It's also not mature yet, and the interface hasn't quite stabilized. I think, barring a whole redesign, this will be the way it goes forward with. Okay, so this talks a little bit more about the invariant stuff I mentioned earlier. But since it doesn't enforce these, it's probably not important. So eventually, I mean, right now, everything that you saw, right, is contracts defined within the class, for the most part, within the class that implements those methods. Ideally, in the future, you'd want to be able to define contracts as part of a module and then apply that module to the class in question or to the object in question. You can do something similar by defining a superclass that defines purely contracts and then have subclasses inherit from that superclass, and then all subclasses are checked as per the superclass. And you don't actually have to define them in the superclass. You can just define the contracts themselves and make sure that they correspond to a method name. Actually, at this point, I guess I'm going to drop out and try to do a demo with this stuff. If that would be probably a little bit more useful than doing this. Is this a good text size? Can everyone see that? Yeah. So let's say we had, I think the canonical example here is a bank account. So let's create a bank account method, and I'm going to use my local copy of Handshake rather than the gem, just because I disabled the debug stuff because it looks a little weird in IRB. But so say we have our class bank account. Well, let's not include Handshake yet. We know certain things that we want to be true about the bank account class, right? We know that we want the bank account to always be positive. The number that a bank account contains can never be negative. But let's go ahead and sketch out these methods. So let's say a bank account starts with a balance. let's say there's a deposit method. And a withdraw method. That looks reasonable. Yes, I got everything. So drop into IRB, and let's see, BA is a new bank account. So we have a bank account we can withdraw. But we can also withdraw too much, right? So now we have a balance of negative 550. That's not what we want from a bank account. And you can enforce that obviously by doing something in here, right? You can raise argument error if amount is greater than or equal to at balance. But then, not only does that code clutter up your method a little bit, it's a little bit ugly, but it also limits it to this particular implementation of the method. And it's not totally secure, right? I mean, you could imagine circumstances, for instance, using instance variable set, in which this thing could be skewed into a situation in which that simply didn't hold true anymore. So you can define, we can include Handshake, and at a bare minimum, we can define a class invariant. We can assert balance is greater than or equal to 0. So that's our class invariant. And if we delete this, we drop down into IRB again. If we say BA is bank account dot new negative 500, we get a handshake violation. Invariant violated by constructor of class bank account, balance must always be positive. So it even uses the error message that we've defined. And you can do other things too. You can, let's say you wanted an accessor, contract, reader, balance. And I think I have a clause defined as non-zero, but that's obviously not particularly useful. So let's define. There's a neat trick I learned not too long ago. I don't know if anyone's seen this. Infinity is equal to 1.0 over 0. You guys seen that? Isn't that just the coolest thing? Check this out. Okay, so positive n equals 0 to infinity. So if we define this up here, right, this is just a range. A range has a triple equals method. So now we have a positive number we can use. And so when we do def initialize, we can apply a contract to initialize, and we'll say positive n return self, deposit. We can do a couple of things. Well, deposit just has to be a positive number again, right? Since this is just returning the value of the deposit. Oh, oops, sorry, it's just going to return, yes. Okay, so that's a very simple contract. Withdraw, contract, positive number, positive number. So now, if we go in here, well, I think, okay, so actually, yes, if we go in here, BA equals bank account.new. Oops, yes, we need to give it a value. If I do BA.withdraw negative 500, the contract just got more specific. So if you look at the actual error message that we got back from this, it's no longer an invariant check failure. It's actually a failure to the call to the withdraw method. It'll tell you the class and the method name. That's not as good an error message as it should be. You can get considerably better in terms of blaming a particular method for having violated a contract. But it does get you a little bit more specific. And finally, you can add a little bit better logic, right? You can tell it, don't withdraw an amount. If you want to define a contract directly on the method that tells it not to withdraw too much, you can define a precondition on that method. And you can say assert amount is, goodness, what is it? Is less than or equal to, what just happened? Like searching.
I just lost that.
Goodness gracious. That doesn't seem right.
No, it's working on it.
Okay.
It's probably just gonna.
Maybe did my laptop turn off?
Your laptop died.
Oh, okay. Well, anyway. You saw where I was going with that.